Welcome to our seminar on preventing lightning damage. In this presentation, we hope to provide an easy-to-understand explanation of the different types of lightning damage and how to protect yourself from it. Here is an overview of what we're going to talk about in this seminar. We will start with the different types of lightning damage. Lightning damage can be divided into two main categories: lightning strikes to structures and surges. Lightning strikes to structures are electrical discharges that occur between clouds and structures or the ground. A surge is when lightning causes abnormal voltage and current between metal power lines and the ground due to the sudden change in the electromagnetic field from the lightning. Damage from lightning strikes to structures can be life-threatening. They can cause fires in structures that are not suitably protected. Lightning strikes can also directly cause damage to structures if they don't have a lightning protection system installed. The main type of damage caused by surges is malfunctions and failures in electrical and electronic equipment. Electrical and electronic equipment has a voltage limit known as the withstand voltage, and most surges have a voltage that exceeds this withstand voltage. This means that if there is a surge on a line, the equipment connected will experience insulation breakdowns as well as general breakdowns and malfunctions. To reduce the risk of damage from lightning strikes, it is important to have an external lightning protection system, or LPS, that safely guides the lightning current to the ground. An external LPS is a lightning protection system consisting of an air termination system, a down conductor system, and an earth termination system. It is impossible to prevent lightning because it is a natural phenomenon caused by the insulating properties of the atmosphere breaking down, leading to an electrical discharge. However, by safely guiding lightning currents to the earth using an LPS, the damage caused to structures by lightning can be greatly reduced. Installing an SPD or SIT is an effective way to minimize surge damage. Installing these on metal lines serves as a way to suppress surges from lightning, which in turn helps protect equipment from surges. A surge protective device, or SPD, is a device that reduces surges from lightning by discharging the electric current from the lightning into the ground. With an SPD installed on the line, surges from lightning can be suppressed to below the withstand voltage of electrical equipment. This can help prevent breakdowns and failures of electrical equipment caused by exceeding their withstand voltages. A surge isolation transformer, or SIT, is a device that keeps lightning surges out of equipment by insulating the power supply side from the equipment side against surges from lightning. The primary and secondary windings of the SIT are insulated with a high withstand voltage, which keeps out surges from lightning. This table shows a comparison between SPDs and SITs. The advantages of SPDs include their small size and low cost, but on the other hand, they can be damaged by large surges from lightning. They also require regular replacement. An additional concern comes from the fact that there are many installation requirements that must be met in order to provide sufficient protection. On the other hand, SITs promise more effective protection than SPDs, and the installation requirements are simple. SITs have the advantage of longer lifespans than SPDs, but downsides include the fact that many of them can be large and expensive. Which of these products to choose should be based on factors such as cost, installation location, and the importance of the equipment to be protected. This slide shows our LPS-related products. For air termination systems, we offer umbrella-style lightning rods under the product name Paracatch. Paracatch ensures that antennas installed on top of steel towers are within the zone protected by lightning rods. For down conductor systems, we offer high insulation cables. For earth termination systems, we offer an earth-enhancing compound called SAN-Earth, which helps reduce grounding resistance. We also provide consulting on grounding using this product. This slide shows our SPD products. We provide SPDs suitable for various types of wiring, including power supply lines, communication lines, coaxial cables, LAN cables, and more. Power supply lines are more likely to experience larger surges from lightning than communication lines. Without an SPD, surges on these lines could cause sparking or even explosions, leading to serious problems, such as fires. This video shows a test using an impulse current generator. A coil component is connected to the output terminal of the generator. If a current equivalent to lightning is passed through the coil, it will burn out instantly. In the next test, current is applied with an SPD connected in parallel to the coil. This time, the coil does not burn out. As you can see, connecting an SPD like this helps protect equipment from surges caused by lightning. Communication and signal lines rarely experience surges as large as the ones that can happen on power lines. However, communication equipment is particularly vulnerable to overvoltages such as surges, which can cause equipment failures. This video shows a test of our communication SPD. Two LEDs are connected to the impulse voltage generator. One LED is protected by the SPD, and the other is unprotected. We apply an impulse voltage to both LEDs simultaneously. As you can see, the unprotected LED was broken, but the LED protected by the SPD was not. Finally, here are some of our SIT products. Shown on the left is an SIT for power supplies. Shown on the right are SITs for telecommunications. We also offer SIT products for LANs. For more information on our products, please visit our product page on our website. That concludes our seminar. Feel free to contact us with any questions you may have about preventing lightning damage. Thank you for watching.